So let's talk about circuit breakers. Circuit breakers prevent cascading failures. Seems like big words, but let me help you understand. So basically cascading failure implies failure in one leads to failure in other, failure in that leads to failure in third, then fourth, then fifth. It's cascaded downwards, right? This is what your basically cascading failures is all about. Now let me take a very practical example to tell you what cascading failures is, how it leads to complete outage, and how you solve it with circuit breakers, right? Circuit breakers, like load balancers, are very important infrastructure component when you are designing for resiliency, that no matter what happens, you would want to minimize the times that you are having complete outage. Partial outages happen every now and then, but you don't want a complete collapse of your infrastructure. Circuit breakers play a very important role in doing that, or rather to be clear, in ensuring that, right? Okay, so let's say we are building a social network that serves, and we are just focusing on feed of a particular user, right? We have a feed that is being served to a particular user. Now the feed service depends on the recommendation service, that hey, you might have some recommendation service that is generating items that you could put into the feed of a user. You might want to also put something which is trending at the moment into the feed of the user, right? Now when you have this, you have your trending service now depends on the post service to render the post. Let's say trending service generates, hey, these are the IDs of the post which are trending. So your trending service now depends on the post service to get those details. But the post service needs profile information to render it. So your post service depends on the profile information. Recommendation service has the posts that are there, but it also is dependent on profile service to get the profile information. Now all of this is combined into feed and which is being served to the user, right? Now if you look closely, your profile service also depends on profile DB from which it is getting the data, and your post service depends on post DB to get the post data, right? Okay, now this is a hypothetical situation, but very similar to what other services might be dependent on. The focus here should be to understand what cascading failures are rather than anything else, right? Okay, now let's say due to some reason your profile DB is under heavy load. Now what would happen? If your profile DB is under heavy load, the request that is being made by your profile service takes longer than usual to get the profile information, right? Now if the profile DB is overwhelmed, profile service response time shoots up. Now any service that is dependent on profile service would become slower, right? So let's say post depends on profile service, that would become slower. Trending depends on post, that would become slower. Recommendation depends on profile, that would become slower. But now slowness is fine. Now you'll say, okay, my DBs are okay, like my DB is under load. I would have something happening really slowly. Why is that a problem? The problem starts to kick in when it becomes too slow, because when it becomes slow, which means your connections, your HTTP connections are open for a long enough time, which means that because your connections are open for long enough time, the request that is being sent, like you're hogging the TCP connections there. Because they are not terminated, every machine has a limit on the number of TCP connections that it can handle. Now when that happens, you are reducing the amount of, or rather you are reducing the throughput of that service. Now if it becomes slow enough, whenever you establish an HTTP connection with other service, there is always a timeout associated with it. Let's say the timeout is 10 seconds. When a service is slowing down, what happens is a lot of requests gets hogged up. The requests that are not served in 10 seconds, those connections are broken, right? So now slowly and steadily, what happens is this service starts to get degraded performance. A lot of requests starts to break over here. A lot of requests starts to break over here. So that slowness of your database starts to break everything slowly and steadily, right? Now, worst case, if it becomes too choky, it becomes like, because the incoming requests are not getting lesser, they are also there, they are continuously coming, right? So this would amplify the slowness, make our entire infrastructure suffer, and slowly and steadily it would lead to a big outage, right? Now this typically happens when one service transitively depends on other service, and which is where you don't want slowness in your system. It's not just for performance sake, but also for outage sake. When things become too slow, too overwhelmed, things typically go south and things break down, right? So this leads to outage. So slowness in one database transitively cascades the failure to upstream, seeing you're taking down or collapsing your entire infrastructure, right? Now you want to prevent this. If you look carefully, we could have prevented this if, for example, if your recommendation service knows that, hey, profile service is having an outage, let me not make a call to profile service. If that is possible, that if your recommendation service can serve without having profile information, hypothetical use case, if you can serve that, if you can serve without making a call to profile service or without serving the profile in the recommendation feed, go for it, right? So which is what the concept of circuit breaker is all about. That if, like, whenever you are making a call to a service, you would only make a call only if that service is healthy. If that service is unhealthy, you don't make a call. You return some default stuff. Let's say in case of this, if profile service is unavailable, your recommendation service just renders a default profile. Maybe it takes from your client side and just renders it, right? So you don't worry about, like, the solution of the default value depends on the use case that you are building, right? But the idea is you can either serve the information without that information, right? So in this case, a recommendation service is not able to make call to profile service because profile service is down. So recommendation service either does not send the profile information or sends the default value for that, right? Now it depends on what your use case is, on which behavior you would want to go for, right? So that is what a circuit breaker is all about. That you make a call to another service only if that other service is healthy. Otherwise, you don't make that call. Because if the service is down and you are making a call to that service, this would lead to timeout. There would be a lot of pile up happening over here, which would degrade the performance over here, which would give very poor experience to your user. And eventually it would make your entire infrastructure collapse, right? So this is how your circuit breaker prevents cascading failure. Right? Now let's go into practical things. How do you implement a circuit breaker? Circuit breaker is not it's not a database that you can spin up. Right? It's something that you have to implement. It's very personal to a use case, to a product. Right? So the idea of implementation of a circuit breaker is that have a database in which for every service, it's a NIME implementation at the moment. In a database, for every service, you are storing the healthy status of it. Healthy or not, yes or no, right? It is not automatically populated. Don't think of it in an automated way. Someone is saying that, yes, I want to make call to this service, right? So it's yes at the moment. If it's yes, people make call, or true, then people make call. If it is false, people do not make call, right? Now one service before making call to other service checks this database and says, hey, is that other service healthy, or can I make call to that? If it gets true, it would make that call, otherwise not. So a simple diagram that to help you understand how it would look like is have a separate database called circuit breaker DB. Build your own schema. Simple key value would work, like put it in a relational DB and just keep querying before you make a request to any other service. So your feed service, your recommendation service, your trending service, your post service, your profile service, everyone is talking to circuit breaker service before they make any request to any service in general, right? Now, if in case you know that your profile service is down, you immediately go and flip in the database that, hey, profile service is down, don't make any call to that. So when recommendation service makes a call to profile service, it would first anyway checking the database, hey, profile service is down. So it skips making a call to profile service and serves the default value or does not serve that information at all, depends on the use case. But you are not letting your infrastructure collapse. Very important, right? So in case of outage, and what I explained is a manual way of doing it. In some sophisticated organization, you might find an automated way of doing it, but start simple. Don't go into complex stuff right away. Don't think of automation on day zero. Start simple. Let someone know, okay, this is down. Let me go and flip the config in the database directly. Done and dusted, right? And then you automatically detect outage and healthiness and whatnot, and then you make things complicated. But understanding the concept of circuit breaker is really important. Implementation specific to organization, specific to you, specific to your team's abilities. Implement however you want. Right? Now this is the concept of circuit breaker. Now, as part of exercise for this video, what I would like all of you to do is implement a circuit breaker. Implement a very simple circuit breaker database in which you are storing the healthiness of each service, or rather not really call it healthiness. Should I make call to this service? That's all it would answer, right? For a given service, is people allowed to make call to this service? Yes or no, right? True or false. You store that part. Build a simple post service that is serving post. Build a simple profile service that serves profile. Let's say post service invokes profile service for this information. But before making that call, let's say your service always checks this DB that should I make a call? Should I make a call? Should I make a call? If it says true, then you make a call. Otherwise you don't. Implement this, right? And trip the circuit. Assume that your post service is down. You manually go and change in the database and see that you stop making call to that service. Right? It seems straightforward, but I would highly recommend you to implement it, to go into those granular details, DB schemas and whatnot. Right? You'll have fun implementing it. Right? This is what circuit breaker is all about. Now, you could spot the bottleneck. That if for every request, every single service is talking to this database, then this database would be overwhelmed. Then worst case, if this database itself goes down, then what would you do? Right? So that's where you don't typically query for every single thing to this DB. You typically would want to cache this information within your API servers itself. Right? But when you do it, what happens when you change a configuration? Right? How would these servers know about it? Implement this part. Right? Don't just first start with implementing, you directly hitting this for every single request and then you deciding to make a call to that other service. As part of optimization, start to cache the information of the services that you are dependent on the API services itself. Right? When you do that, then what happens when someone changes the configuration? How would the servers know about it? Right? That's where, see if you can leverage Redis PubSub. Right? In the previous videos, we looked at Redis PubSub for real-time communication and configuration push. See if you can leverage Redis PubSub to make it reactive. You'll have quite a fun implementing it, and I would highly recommend you to implement your own circuit breaker and see how you can leverage Redis PubSub into making it better and almost real time. Right? So yeah, this is what I wanted to cover in this one. I hope you found it interesting. Hope you found it amusing. That's it for this one. I'll see you in the next one. Thanks a ton.